Now this is Maxima and Minima Part 2. Before watching this video, I recommend all of you to kindly watch Maxima and Minima Part 1, right? So this question says, if the curved surface area of the right circular cylinder inscribed in a sphere of radius r is maximum, right? Show that the height of the cylinder is root 2r. See, we have a sphere. Let me draw a 2D figure. It is something like this. We have a circle whose radius is r. There is a cylinder inscribed. So inscribed means from the front we may be able to see a rectangle actually, because this is 2D figure, right? So we'll be seeing something like this. So we will do one thing. He has given that the radius of the sphere is r. That means this is r, right? Now let h be the height of the cylinder. That means this is h, right? And let capital R be the radius of the cylinder. Okay, that means this is capital R. So this length should be h divided by 2, of course, because this is half of the length. So from this triangle A, B, C, by Pythagoras theorem we can say h by 2 whole square plus capital R square is equals to small r square, right? That means h square divided by 4 plus r square is equals to r square, right? Or don't forget to include an imply sign. So h square plus 4r square is equals to 4 times r square. So I hope we understood till here. Now see, what should we minimize or maximize? Curved surface area of the right circular cylinder inscribed in a sphere of radius r is maximum, right? That means the curved surface area of a cylinder has to be maximized. So let C be the curved surface area of cylinder. And what will that be? 2 pi, and the radius of the cylinder is capital R and height is small h. Right, now the main important thing is here we have r and h, and here we have h square. So what should we do? We will do one thing, we will square it. So c square will be 4 pi square r square h square. This step is very important, students, because the minimum or maximum of this value of c, wherever we get the minimum or maxima for c, at the same location we will be getting minima or maxima for c square as well. So that is a very important step. So what is convenient for us? I think we can write h square is nothing but 4r square minus 4r square. So we can take 4 common. So we'll get this value. Now c square, let s be equals to c square, and that should be equals to 4 pi square r square into, instead of h square we can write 4 times r square minus r square. So we will do one thing. Let this be a function of see, what is the variable here? Capital R is the variable. Think about it. See, this cylinder is we can get many such cylinders, no? That means the radius of cylinder is varying. So let us write it as f of r. So f of r is 4 pi square r square into 4 pi square into 4 is 16 pi square r square into r square minus r square. So let me take this r square inside. We get capital R square small r square minus r square into r square is r power 4. I hope you understood this. Now for minima or maxima we have to differentiate it with respect to capital R. So the derivative of that will be 16 pi square is a constant, derivative of r square into r square. Now this r square is a constant, so as it is, and derivative of this r square will be 2r, minus derivative of r power 4 will be 4r cube, right? Is this understood? We can take this 2 also outside. We get 32 pi square into, if I take 2 outside, we get r square r minus 2r cube. I hope you understood this. We have taken 2 common. Now for minima or maxima, f dash of r should be equals to 0. That means 32 pi square into, now this should be equals to 0. That means 32 pi square, if I divide with 0 we get 0. So we get r square into r minus 2r cube equals to 0. We can take r common here. We get r square minus 2r square. So either r is 0 or r square is 2r square. That means r is equals to root 2r. Strictly speaking, we should write plus or minus, but radius cannot be negative, so we are writing root 2r only. Now, is this case possible? When r is 0, think about it, there is no cylinder, no? If there is no cylinder, how can we get maximum curved surface area of cylinder? So this should not be possible. Anyways, we will go with the procedure. We have to once again differentiate this expression. We have to once again differentiate this expression for minima or maxima, right? So f double dash of r should be 32 pi square, and derivative of r square into r should be r square into 1 minus derivative of 2r cube should be 2 into 3r square, right? So we get 32 pi square into r square minus 6 capital R square. So let us replace. So here capital R will be r by root 2. See, if I take capital R as 0, so anyways, if I take, let us write it. If capital R is 0, then f double dash of r will be 32 pi square r square minus 0, which is greater than 0. And we get minima because double derivative is greater than 0. But if capital R is r by root 2 or capital R square is r square by 2, then f double dash of r will be 32 pi square. Replace r square with small r square divided by 2, so we get r square minus 6 into r square by 2. So we get 32 pi square into r square minus 3r square, which is 32 pi square into minus 2r square, and this is negative. Therefore, we get maxima when capital R is equal to small r divided by root 2. Now, but we want to show that the height is, I think we have to show that the height of the cylinder is root 2r. So for that, we will be using this expression. We have h square, I think, plus 4 capital R square is equals to 4 small r square, right? Capital R square is small r square divided by 2. So we have h square plus 2r square is equals to 4r square, and therefore h square is equals to 2r square, and therefore h is equals to root 2 times r. I think we have to prove this. Hence, proved. So I would recommend all of you to kindly watch this video once again, because this may be a little confusing for you. Now let us go to the next question, the last question from this topic. It says, a wire of length L is cut into two parts which are bent respectively in the form of a square and a circle, right? So there is a wire L, wire of length L, which is bent into, which is cut into two parts, right? So let us say this length is x, then this length should be L minus x. I hope you understood this. So it is in the so again, after cutting, it is bent in the form of a square and a circle. That means something like this, square and a circle. So we'll do one thing. We'll take the side length of square as a and radius of the circle as r, right? Is this clear? So basically, what is the first condition? The perimeter of this wire is L, and that should be equal to sum of perimeters of square and circle. That means L should be equal to perimeter of square is 4a and perimeter of circle is I think 2 pi r. Yeah, it is 2 pi r. So let us name this as equation 1 or relation 1. We will be using it later. Now, what are the lengths of the pieces of the wire respectively, so that the sum of the areas is the least, right? I think you understood this. Now we have to write the expression of area. Area of square is a square and area of circle is pi r square. So we have to write the expression in terms of area. So either we can convert r in terms of a or a in terms of L, whichever you like, it is feasible. So we will do one thing. We will try writing a in terms of L and R. So that means L is equals to 4a plus 2 pi r. L minus 2 pi r is equals to 4a, and a is equals to L minus 2 pi r divided by 4, right? Is this clear? Hope you understood this. Now we will be inputting this in this particular equation. Capital A will be, instead of a square we can write L minus 2 pi r divided by 4 whole square plus pi r square, right? So this is the expression of area in terms of right r. So let us write a of r. No? For minima for minimum or maximum we have to differentiate this with respect to capital R. So a dash of R will be derivative of something to the power 2 will be 2 times something into derivative of something. That means once we write this, derivative of this also we should write derivative of L minus 2 pi R divided by 4 should be 0, because derivative of L is 0. Derivative of 2 pi R should be 2 pi. We have a minus sign, so we are placing a minus sign and divided by 4 as it is as a constant. I hope you understood this. Derivative of pi R square should be 2 pi R. So ultimately we get, so this can be cancelled. We get L minus 2 pi R divided by 2 into we have minus 2 pi by 4, that can be written as minus pi by 2, this value, plus 2 pi R. Now I think if we multiply this, we will be getting minus pi L plus 2 pi square R divided by 4. I hope you understood this step. So we have 2 pi R here, right? Yeah. So this is the expression for this a dash of R. For minima or maxima, first derivative should be equal to 0. That means minus pi L plus 2 pi square R divided by 4 plus 2 pi R is equals to 0. So let us take the LCM. We get minus pi L plus 2 pi square R. 4 times 2 pi R is 8 pi R divided by 4 is equals to 0. Cross multiply. We get minus pi L plus 2 pi square R plus 8 pi R is equals to 0. I think we can easily take pi common. So we get minus L plus 2 pi R plus 8 R is equals to 0. Pi cannot be 0. That means minus L plus 2 pi R plus 8 R should be equals to 0. And 2 pi R plus 8 R will be equals to L. I think I can comfortably take 2 R common. We get pi plus 4. So basically R is equals to L by 2 times 4 plus pi, right? So this is one value. And now we got maxima or minima. Now for that again, now this is the expression for a dash of R. Now we have to once again differentiate this, right? So right, a double dash of R will be now derivative of this part. So we have to differentiate with respect to small r. So derivative of minus pi L will be 0 anyways, because that is anyways a constant. And derivative of 2 pi square R will be 2 pi square plus 2 pi square, and 4 is anyways a constant in the denominator, so it will be as it is. And derivative of 2 pi R here will be plus simply 2 pi. And this value is greater than 0, so therefore we get minimum area. Correct now? Yeah. Think what are the lengths of the pieces of the wire respectively, so that the sum of the areas is the least, right? And we want minimum area, right? That means this is the acceptable value of R. Now we have to find the value of A also. For that we will be using this expression. A is equals to L minus 2 pi R by 4. Now what is the value of R? R is basically L divided by 2 into 4 plus pi. Now this is divided by 4. 2 and 2 gets cancelled. Now I think I can take LCM. It will be L times 4 plus pi minus pi L divided by 4 into 4 plus pi. So what do we get here? So this will be 4L plus pi L minus pi L divided by 4 times 4 plus pi. So pi L and pi L gets cancelled. Ultimately we are left with 4L by 4 times 4 plus pi. So 4 and 4 gets cancelled. Basically therefore A is equals to L by 4 plus pi, and what is R? R is equals to half of this, L divided by 2 times 4 plus pi, right? So I think he's asking us to find the values of what is he asking? What are the lengths of the pieces of the wire? So we need to find the length of the pieces. So length of square is I think 4A, that should be 4L by 4 plus pi, and length of circle, that means perimeter, should be 2 pi R. So that should be 2 pi into R is L divided by, so it is pi L divided by 4 plus pi. So you can cross check. If you add these two, 4L plus pi L. You can take L common, you will get pi plus 4, that will be equal to anyways L. So that should be the final length. That's it. So I think we are done with it. Thank you for watching this video, dear students. If you are finding it a little hard, I recommend all of you to kindly watch it once again and practice it. These are very, very important questions.